Hello, Josh. How are you today?
Not too bad, Roger. How about yourself?
Well, doing very well. What are we going to talk about today, Josh?
Well, I thought we'd maybe have a chat about security and what type of security is offered with Turnium's SD-WAN product. How's that sound to you?
Oh, that sounds like a great idea. That's one of the questions that our partners and potential partners ask all the time.
Awesome, awesome. Well, first off, I want to say, if you've got a bond defined with us in our product here, and in particular, if you have multiple circuits or legs, as we like to call them, you've already got a certain amount of security built in because of the fact that using our balancing algorithms, you're never going to get a complete picture going up one leg or one circuit. So even if some traffic was intercepted at that level, the balancing algorithm is going to be splitting up where the different packets go, and you're never really going to get a full picture of that. But regardless of that, we've got some industry standard protocols that we also use, which I think would be great to talk about.
Okay, great. That sounds pretty good that this product is secure right out of the box, even without enabling encryption.
Yeah, so let's talk about our first level of protection that we can add on top of that. And I'll just let you get into the edit mode there, and we can go look under tunnel security. The first one we should talk about is right at the top of the list there, HMAC, which just stands for hash-based message authentication codes. And that means that the data that's being sent between the edge node and the core node is signed and verified using an HMAC code. The algorithm uses an MD5 hashing and 30-byte secret key. What's important to understand about this mode, Roger, is it offers data integrity, but not secrecy. So to get into that a little bit further, a receiving host can detect if an attacker has changed network data after it has been sent, but the data is not hidden, and it can be seen by anyone with access to the networks between the edge node and the core node. But if that's not going to work for you, then that's where encryption comes in. And so if we turn encryption on, now that session between those two nodes is encrypted using DTLS 1.2 protocol, which is based on SSL/TLS, which are two protocols that are very well defined in RFCs. With that, we use two industry standard ciphers, AES 128 and 256. That allows us to indicate that SD-WAN offers what we call perfect forward secrecy with all ciphers. Perfect forward secrecy is the property that encrypted traffic cannot be decrypted at a later time, even if the private key is compromised. The other thing I want to mention with this encryption is that we encrypt at the link or the leg level. Right? So for example, if you've got a bond set up and it's got 3 links or legs, we would use 3 independent encryption sessions, and those sessions renegotiate keys at an interval that can be defined by the user based on what their needs are.
Wow, that makes this really, really secure. Not only am I encrypting every session across a leg or a link, but I'm ever only putting part of my data down a link at any given time.
That's correct. That's correct. And so the other thing we're going to want to show here is, yeah, if you go ahead and turn encryption on there, Roger, and save that bond, and then we back out into the multiple bonds view, now you can easily go over to your options there, and you can hover over that lock exactly, and you can see that encryption is enabled. So you've got these easy visual cues where you can go through your lists of all your deployed sites and see exactly what's going on in terms of what level of security you've applied. The other thing I'll mention about the AES encryption is that it does incur a little bit of overhead on the CPUs, which can result in reduced throughput. However, most Intel chips these days have an AES instruction set that supports offload and greatly reduces that overhead, which means the end result is using these industry standard ciphers with Intel chips or chips that support AES offload in general means that you're going to get really good security, and you're also going to get really good performance and ROI on those devices that you're deploying.
Wow, that's great, Josh.
Yeah, exactly. Anyways, Roger, I think that's all we wanted to cover in today's video. I think we've put out some good information here, and I look forward to chatting with you on the next one.
Great. Thanks for chatting with me today, Josh, and giving an overview of encryption.
Awesome.
Take care.